Welcome to this very special episode of the Swim Swam podcast. I have four guests with me today. I'm going to try to keep this intro brief, but they're all very credentialed in the academic and athletic world. First off, we're going to hear from UVA's Ken Ono, who is a STEM advisor and mathematics professor at the University of Virginia. In the classroom, Ono specializes in number theory and studies highly abstract problems involving patterns and properties of numbers that have perplexed mathematicians for centuries. His work has earned him coveted Sloan Packard and Guggenheim fellowships, as well as leadership roles as vice president of the American Mathematical Society and as chair of the mathematics section in the American Association of the Advancement of Science. I was exceedingly nervous to read all that, but Ken, thank you so much for joining us. We're also going to be hearing from Jerry Liu, Kate Douglas, and Claire Curzan. I'm going to give them their intros once we get to them. Ken, I want you to start. You are hosting an independent study this semester with a number of UVA swimmers, as well as Mr. Jerry Liu. Can you tell me a little bit about the study and how this came to be?
Sure. Well, first of all, Coleman, you're too kind. I wish I had your hair. I've lost mine in COVID. So first, a little correction. Jerry is now a graduate student at MIT. He graduated with honors from UVA in the spring, and he's been working with me for a number of years. And he in a few minutes, he'll show you one of our cool secret tools, secret weapons. As I think you know, Coleman, I've been studying swimming for probably 8 or 9 years, dating back to my years as a professor at Emory, where I worked with Andrew Wilson, Amanda Weir, and Maddie Locus, among many others. And where we are today is sort of, where we are today is built on a lot of that work. And over the years, we've been collecting accelerometer video data of some of the best swimmers in the country. And we've been studying that. And well, a few weeks ago, Todd on deck just said, you should really have a class. I was talking about how we're really fortunate at the University of Virginia to have great student athletics, great student athletes, and Claire and Kate, two supreme examples. They'd be star students independent of whether or not they swam. And so I think he was kind of joking about that, but well, here we are today. And I think we sent out a text to some of the students to see if there would be interest. And I think 9 or 10 have signed up now. And so here we are. We're a few weeks into the course. So we've only done 3 modules. And Claire and Jerry can tell you about how far we've come in the coursework. And I hope they're excited by it. But by the end of the semester, I think they'll have a completely different perspective on swimming.
I'm certainly excited to hear about the first few weeks. So this independent study came about basically as a joke, which is very easy for me to believe. It sounds like something Todd would say, but it is cross-listed in data science, math, and statistics. It is learning methods for elite swim analysis. And now I'm going to throw it over to Jerry Liu, who, as Ken said, has a BA in systems engineering and economics from Virginia. He is a master's in financial engineering from MIT, which I think is where you're at now. And you are the technical performance consultant for Virginia Swimming and Diving. Jerry, you've worked with Ken for quite some time now, as he said. How have you seen this system evolve? And can you tell me a little bit about this independent study as kind of the culmination of that work so far?
So I started with Ken in 2019, and my first athlete that I studied was actually one of my teammates, Phoebe Bacon. And that was when we were actually still plastic wrapping sensors onto athletes' torsos in order to make sure the sensor stays in place. And that was when we were doing a lot of coding for every single visualization we want to show. And it's just very, very time consuming. And since working with Ken since 2019 till now, we have perfected, I don't want to say perfected, we optimized a lot of the workflow that usually takes us a lot of time to do. And we can do that very, very quickly now. So we have sort of democratized this ability to put athlete performance under the microscope across the team. That's a quick overview of how the project has gone since I've gotten here. So after a test session with an athlete, right? We have a test planning session with Ken, with Todd, with the athletes, with our analysts. And after an actual test session in the pool with the athletes, we extract accelerometer data from our sensors. And the accelerometer data is a block that looks like this right here. This is a 512 hertz accelerometer, inertial measurement unit. It means it collects 512 acceleration events per second. This time series data, all you see here is within about 5/10 of a second here. For every 1/100th of a second, we have 5 data points displaying the propulsion or drag of an athlete in 3 directions, as well as the orientation they are in the water through these directions. So you can see here the total data points we have here is 15,590 for about a 20-second performance. So we're able to break down the performance in very, very small details. So this block of numbers right here, it doesn't really make sense unless you can visualize it properly. And therefore we developed this secret toolkit that visualizes this performance data for easy analysis and manipulation, which is our web-based toolkit that all of our analysts or all of our students will be trained to use and in order to manipulate data quickly. So here you can see, obviously Claire haven't gone through yet. Claire will give it like a more detailed demonstration of what everything means. But here you can see the 3 axial directions, X, Y, or X, Y, and Z, but we put Y, X, Z for reason I'll explain in a second. Y here means propulsion in the direction that we want the athlete wants to go, so forward, back. X measures rotation, and Z measures undulational acceleration. So the combination of these 3 acceleration streams allows us to completely look at a swimmer's performance in, I guess, in very small detail. So here you can put any performance under the microscope. And as you can see here, if we really want to look at the turn going into the first dolphin kick, we can zoom that in. We can adjust the axes to, right? So here you can do a lot of manipulation with our tool to truly analyze the performance under the microscope. This combined with video, we're able to actually pinpoint inefficiencies. So in this case, we have visualized swimmer A's butterfly. We can compare different swimmers' execution of butterfly to look for comparative strengths and, I guess, target of opportunities. I can overlay swimmer A's butterfly with the butterfly stroke of swimmer B. I can line them up. One of our students in our independent study will actually call this racing a Mario Kart ghost, which is a pretty accurate description of essentially what we're able to do here. We're actually able to race swimmer A and swimmer B without actually racing them. We're actually racing their accelerations and racing how well they move through water. On top of that, we can essentially simulate a race of any swimmer against any of our national team athletes we have in our database. So we are obviously, Claire will tell you more about show you an example of an analytical process, but we are constantly pushing new tools to add to our toolkit, which Claire and Kate would get to use. By the time they actually start, we'll push 2 new features that allows for easy computation of propulsion and tempo decay throughout a length. And we're also developing a video data stream pairing feature that shows data and video side by side for easy analysis of executions of races.
Coleman, I do have one comment to make, and the comment I want to make is that we're not revealing everything that we know for obvious reasons. So what Claire will be talking about is just what we've learned through modules 1, 2, and 3. And I think that is already probably will give a pretty good indication of some of the other tricks that we.
Just for reference, before I hand it over to Claire, how many modules will be involved in this course? So you
right now we've already written the 4th module, and depending on the outcome of the student, the student reports, there could be as many as 10. But by the time we get to the 5th module, I think they will already be doing genuine evaluations of actual swimmers. Right now, what Claire will show you actually does involve 2 human beings, 2 national teamers, but sort of still at the toy model level. But I think you'll see that it's pretty useful.
Okay, so without further ado, 6-time world champion, Olympic medalist, NCAA champion, UVA swimmer and athlete Claire Curzan. Show us what you've been doing through these first 3 modules of this independent study.
The 3rd module has definitely been the most advanced. So I'm just going to backtrack really fast to explain it from the start, because I think that'll just give everyone a better understanding. So basically, Ken and Jerry developed these things called accelerometers. And so they're these little devices that go on swimmers' backs when they're in the water. And so they're able to measure in 3 directions. Y is, as Jerry said, forwards. X is rotational and Z is undulational. So like think of dolphin kicks. So then we're able to track this data. They're 512 hertz. So that's hundreds of images or data points per second, which is compared to a typical video camera only captures around 24. So it's obviously very advanced. This is definitely cutting edge in terms of swimming and swimming analysis. So in the first module, we just were labeling every single spike in this graph. So for example, this is the push off. This would be the dolphin kick, because this is 2 male breaststrokers, national team breaststrokers. So big dolphin kick right here, pull down, and then obviously this is the swim portion, and this would be the breakout. And then module 2 was getting into more nuancy of like, okay, if you're looking at a butterfly, then there's 8 dolphin kicks here, and how many strokes are in this lap. So just breaking down the swim more and more. And then module 3 was probably the most fun. I think everyone in the group agreed. It was comparing 2 swimmers. So just as an example, looking at these 2 breaststrokers, we can see here, big push off. And then if you look at the graph, it measures acceleration on the y-axis. So 0 is you're neither accelerating nor decelerating. So just kind of constant neutral. Positive means you're accelerating, so you're going faster, and negative means you're decelerating. So we want to try to minimize as much as we can what's happening below the 0 line. So as you can see right here, breaststroker number 3, which is the blue line, has a pretty good glide after their push off. But breaststroker 4, very far below the 0 compared to the blue line. So there obviously would not be as fast as breaststroker 3. And what we can also see here is that breaststroker 4 prolongs their glide, which is almost prolonging the pain, because they don't always have the best glide and they're doing it for longer. So even just looking at that small example right there is, you don't even have to improve fitness, but you can already get faster. So I've really enjoyed just like being able to look at swimming from this new perspective, and I'm excited because module 4, we get to start incorporating video. So no longer just looking at graphs and generic names like breaststroker 3. And then pretty soon we're going to actually start analyzing the team. So I'm very excited for that.
Real quick, Claire, I am just curious, you've seen all this data, you've seen the graphs. Has it affected how you, or where your mind goes, what you're thinking about during your actual training and swimming?
Surprisingly, no. I feel like this stuff would really get me excited, and I normally would be thinking about this, but I actually haven't had the accelerometer on me yet. So I don't even know if my glide creates resistance or not. So I'm excited to get tested with it, but Ken knows what he's doing, so I'm just gonna listen to him and Todd.
Yeah, so
Yeah.
Coleman, just if you're wondering about the difference in glide that Claire was describing, you don't want to be the orange breaststroker who's losing a quarter second every time off of every wall and not knowing why. All right. And that's before we've even started talking about swimming. And so as we work through the modules, we'll talk about different technique for individual strokes, timing, everything that you hear about, the typical things that coaches tell you to work on. We'll put numbers to that. We'll put metrics to that, saying, well, it is true that if you improve such and such, our prediction is that you might cut, this much in time. So I think, Coleman, you probably remember at NCAAs, I lost a bet when Gretchen didn't get into the 47s for 100 backstroke. These aren't numbers that we're just like making up, right? These graphs tell us where these targets of opportunity are. And because of our ability to go back and experiment throughout the course of the season, we can see improvements as they're made.
Well, and I know from conversations we've had, Ken, that you've been off on some predictions, but you've also been very on some predictions or areas of opportunities for some of the swimmers that you've worked with, if I'm not mistaken.
I think that's right. But I did think about, I do want to make a point that I don't want you to ask me about what we predict for Kate or Claire moving forward. That's right. It's too early for that. Still getting in shape.
Off the table. Okay, so I think Kate, is it your turn to present at this point?
So I don't really have anything to present because I'm doing kind of a separate project from the rest of the group. I'm still listening into everything that they're doing to help, myself really understand it all better. But I kind of wanted something separate kind of from my own swimming, and Ken kind of introduced me to this project idea, and I got really excited about it. So basically, the premise of the project is we're hoping to design a model for using technology in college teams to help improve performance. And with the help of Dr. Ono, we found and read multiple research articles about studies that have used sensors on individual swimmers throughout a season and analyze that data to try and find an optimal training plan for each specific distance group on a team. And we specifically want to emulate a famous University of Paris study that was published in Nature that analyzed distance running. And I'm going to be specifically looking at the distance group data because I don't want to be thinking too much about something that relates to me. So we figure 200 free and up is where I'm going to be focusing my efforts. But yeah, we really just want to take advantage of using wearables in training and now in racing, since that's just recently become legal. So yeah, I'm looking forward to working with the coaches and helping them evaluate workout and then performance data when it comes time to taper and rest. And yeah, that's pretty much.
And I think, Kate, you should probably add that this includes real-time 100% recording of heart rates. Every lap, every distance swimmer swims moving forward, we will have that data.
Yeah, we're hoping to, right now we're kind of in the collection stage, just collecting as much data as we can from practices. And yeah, one of those measures includes heart rate, also distance per stroke rate, yardage, and all of that.
And can you sorry, I'm still trying to just process all of that. So once you collect the data, how will you use that data and what are you hoping to accomplish with it?
Yeah, so I mean, we're kind of trying to, like I said earlier, I feel like using wearables in training and racing has kind of just becoming more normal. And so we want to figure out like a way to use that to help improve performance and kind of figure out specific training plans. I guess in this distance running Paris study that we are reading, I guess it just, you can kind of tell where like peak performance is and I guess like how your heart rate and how long you stayed in each heart rate zone throughout the season kind of affects your end of season performance, and kind of trying to switch that up if something works better than something else.
If I may add, one of the great things about wearables and all of this data is that it opens up new possibilities for a coach, where a coach can do a better job of assembling a precision training plan geared for the individual. So when you collect data throughout the season, if there's a early December taper meet, you can learn a lot from how your athlete tapered going into that taper meet. And based on that data, you can imagine assembling very high precision, individualized training plans going into championship season. Mm-hmm. Right? If you had the ability to predict that a certain kind of taper will result in a 3 or 4% improvement for some athletes and different kinds of improvement for others, that's the Goldilocks zone. You want to take the guessing out of it, right? You don't want your athletes to get up on the blocks and say, well, I'm here now, I guess I got to go swim, right? It's empowering to the coach and certainly empowering to the athlete when you've done the work, when the hay is in the barn and there's a formula to execute.
So on that note, and I kind of had this question after Kate's speech as well. So is the gathering stage of when you're just gathering all this data, is this going to be, through the midway point of the season, through the entire season? How big of a sample size for Kate's specific project are you shooting for?
Yeah, I mean, I guess for my specific project right now, we're gonna make it to mid-season and kind of use results from performances at mid-season for me to look at, since that'll kind of be towards the end of the semester. And then we're hoping to build off of that. Obviously, a project like this requires a lot of data and probably, years worth of performance and workout data. But so yeah, we're kind of I'm hoping that up to mid-season, I'll kind of use that as like a model for future projects like this.
And as a professor, I do want to say that my goal for Kate, and apart from the out of pool goal, let's publish a paper. Let's publish a real bona fide research paper.
For the uneducated,
yeah, we're hoping.
Go ahead.
Oh, I was just saying, yeah, we're hoping that maybe one day it'll get there.
I only know what publishing a paper means in the scientific world because my brother is a PhD engineer. But for someone who is not in the academia world, what does publishing a paper entail and mean for the publishers?
Sort of what we live for. I think you may have heard Kate say that we're studying this famous Nature paper. I mean, Nature is one of the, that's one of the gold standards in science. And there's a lot of poor science out there. And I'm not saying that just because people don't trust science as much as they did, say, 5 or 6 years ago, but we want to write an article that matters, something that can be replicated. And swimming represents a unique opportunity. A lot of other sports are well known to have already adopted technology. Think about F1 automobile racing. That's the epitome of high tech. And now with the World Aquatics ruling that allows wearables, this is the time.
That's very exciting. I didn't realize you meant, and so Nature, there's like 2 very, very big publications. I don't think they're magazines, but publications, right? It's Nature and Science.
Right. Okay. So as you mentioned earlier, I'm the chair of the mathematics section at AAAS, the American Association for Advancement of Science, and we publish science. So if we do a good job, I would prefer that our work be published in Science as opposed to Nature. I work for science.
Makes sense. So basically, publishing a paper means you do all this research, you put forth your findings, and it is peer reviewed to a point where people are able to revere it as truth. Is that a fair assessment?
Yes.
Okay. Okay. Just making sure, for listeners who, again, are not familiar with the academic process.
Right. We're not talking about rainbows and butterflies here.
We're not talking about swam here, where our commenters are allowed to, publish their feelings without any peer review.
And
So,
you allow commentary.
we allow commentary. But that I didn't realize that you were wanting to take this study that far. I think that's very cool, and I think that's big for the sport of swimming as well as hopefully the world of science as well.
Kate and Claire and Jerry, they're students, right? So that's what we do at university. This Olympic stuff, world champion stuff, that's all on the side.
I've interviewed Claire and Kate many times, and it's very cool to be doing so in this realm, in more of an academia realm, because certainly from our end, we don't see a lot of that come to light, or we don't talk about it because our area of expertise is the athletic side. And so it's been really great to hear the academic side of things, and how we can incorporate swimming into that. I think this is a super cool opportunity. I hope the independent study continues to go well, and these projects and this data collecting go well as also. Claire, can you tell me about this transition to Virginia, as well as being a producer on what I'm guessing is the STEM podcast?
Yes, I'll start with the STEM podcast just because it's an impending event. But tomorrow I'm gonna partake in like my first recording session for a podcast called Who's in STEM, which highlights like recent STEM discoveries at UVA. So Dr. Ono is like the host for the show, and he brings on a lot of really, really talented and very awesome guests. So I had the pleasure of meeting with the director and co-director of the Brain Institute. And so I was able to interview them about just a recent new fund that they got. So I'm excited to record tomorrow and hear more about that. And then I'm very excited to be at UVA. The decision was largely for the Olympics, just to be closer to home and my support network. And I'm excited for all these opportunities that I've been able to find at UVA, working with Dr. Ono in many capacities and also working with Todd. So I've been loving it here so far. Today was really hard practice, but it's been really good. And I've loved racing Kate and Gretchen, and just, I don't know, it's been.
Thank you for that insight. And that's really exciting to hear about the swimming, but also about the podcast, as a fellow host of a podcast. That's super cool. And kudos to you, Claire, and kudos to you, Ken, for getting that off the ground. I know you and I have talked about that before, and it's exciting to hear that it's coming together. Is there anything additional that anyone would like to add?
Kate, Claire, Jerry, they wear many hats. So you might know some things about them, but these are super people. It's a real privilege to work with them.
You've been listening to the SwimSwam podcast. Stay tuned for new episodes every week. You can take SwimSwam podcast on the go by subscribing on your favorite podcast platform. Look for links in the description below, and be sure to subscribe to our YouTube channel for more videos as well.